Electronic circuit and components. An electronic circuit is composed of different components that are classified as passive and active components. Both these classes of electronic components are different from each other. They are lifeline of any printed circuit board assembly. They both play vital roles in the functioning of any electronic device. Electronic components are intended to be connected together, usually by soldering to a printed circuit board, PCB, to create an electronic circuit with a particular function. Type of electronic components. 1. Passive components or device are components that did not generate voltage but controls the current in a circuit. Examples: resistors, capacitors, inductors and many more. 2. Active components or device are components that can generate, amplify and even control voltage and current in a circuit. Examples: diode, transistor, integrated circuits, IC, and many more. Electronic components and devices used in power supply. 1. A resistor is an electronic component that resists the flow of current or the flow of charge in a circuit. 2. A capacitor is a device that stores electrons. 3. A diode is a semiconductor electronic device or component that permits current to flow in only one direction. 4. A transistor is a semiconductor device that is used to switch electronic signals and to amplify. 5. An integrated circuit, IC, is an electronic component that is composed of two or more components integrated in one package. 6. An inductor is basically a coil of wire that may or may not be wrapped around a core. 7. A transformer is a device for converting a varying current from one voltage to another. 8. A fuse is a safety device which used to protect an electrical circuit from the effect of excessive current. 9. A switch is an electrical device having two states, on, closed, or off, open. Resistor is one of the most commonly used in the electronic circuits that requires them to work properly. Resistors are electronic components whose principal property is resistance. They are used to resist the flow of current, limit or divide the current, reduce the voltage. 7. PAGE protect an electric circuit or provide large amounts of heat or light. Resistance refers to the amount of opposition to the current flow in a circuit. It is measured in ohms represented by the Greek symbol omega. Ohm is the unit of measurement used to measure resistance. In June 16, 1959, Otis Boykin earned his first patent for a wire precision resistor, followed by an electrical resistor which allowed for the designation of a precise amount of resistance for a specific purpose. In modern electronics, individual resistors have been completely replaced by the integrated circuit, IC. There are different types of resistors. Types of resistor. Resistors come in many shapes, forms, and sizes to meet specific design requirements of a circuit. The following are the common types of resistors. 1. Fixed resistor. It is a single value resistance, which remains the same under the normal condition. The two common kinds of fixed resistors are carbon resistor and film type resistor. A carbon film resistor, it is made from carbon graphite, mixed with powdered insulating materials. This type of resistor offers high resistance, using low power. Bicarbon composition resistors are made either by hot or cold from mixtures of carbon and clay binder. These has become a dominant discrete resistor mainly for its low cost reliability in general purpose applications. C-metal film resistors are formed by means of vacuum decomposition, a process by which any of several different metal or metal oxide films are deposited on a suitable insulating mandrel or core. It is laser trimmed to obtain the desired resistance value before the protective insulation coat is applied. Wirewound resistor is a type of resistor. Highly resistive wire is wrapped around insulating core. The length of the wire determines the resistance of the device. Insulating cores usually made of cement or ceramic materials or just plain paper or pressed cardboard. This type of resistor provides low resistance with high wattages ranging from 5 to 100 watts or more. They are best choice in applications where accurate and stable resistances are necessary. 2. Variable resistor. Variable resistors are used when it is necessary to change the amount of resistance in a circuit. It is constructed so that its value in ohms can be changed or controlled either by sliding a metal clip contact, as in variable wire wound resistors, or by adjusting the handle or shaft, as in potentiometers and rheostats. The way resistance varies with shaft rotation is called taper of the control. A wire wound type consists of a special resistance wire wound on a porcelain tube and provided with terminals at each end. A metal clip comes in contact with the exposed portion of the resistance wire or base. The metal clip, which slides along the length of the porcelain tube, can be locked in the desired position. A rheostat is a variable resistor with two terminals connected in series with load, the filament of a lamp or vacuum tube. It is used to adjust the current in the circuit. If you decrease the resistance, the current increases. The power rating must be sufficient for the highest current in the rheostat. B potentiometer has a circular disc called the carbon composition element and is provided with 3 terminals. 2 terminals are found at the end of the disc while the third is at the middle. The middle terminal is operated by a shaft that comes in contact with different points on the resistance element when the shaft is manually rotated. Resistor power rating. Power rating of resistor changes with their sizes. The bigger the resistor, the greater the wattages, and the smaller the resistor, the lesser the wattage. Standard symbol of resistors. The symbol used in schematic diagram and electrical drawings for a resistor can either be a zigzag type line or a rectangular box. Resistor color coding. One distinct features of this resistance-giving component is the way its value is determined. Because carbon resistor is physically small, they are color-coded to indicate their resistance value in ohms. The resistance value of a resistor is color-coded. Reading from left to right, the first color band close to the edge indicates the first digit in numeral value of resistance. There are 4 or 5 color bands on the body of a resistor. In 4-band resistors, the first band is the first significant digit, the second band is the second significant digit, third band is multiplier, and the fourth band is the tolerance. In 5-color band, the first band is the first significant digit, the second band is the second significant digit, third band is third significant digit, and fourth band is the multiplier, and fifth is the tolerance. Black is not used for the first color or digit. Gold and silver are only used for third and fourth digits. Resistor tolerance. Resistor color-coded value is not absolute. The real resistance of the resistor is sometimes lower or higher than its color-coded value, but not to exceed its tolerance level. Tolerance is the limit on how far the real value of the resistor can deviate from its color-coded value. It can be more or less, but subjected to a tolerable limit. In color coding chart, there is a column for tolerance. Color gold is plus or minus 5%, silver is plus or minus 10%, and the no color means plus or minus 20%. Procedure in interpreting the tolerance of resistor. 1. Identify the tolerance color of the resistor being analyzed. Assuming the color is gold, which has a value of plus or minus 5%. 2. Convert the percentage into its decimal equivalent. 5% is equivalent to 0.053. Compute for the percentage of the color code value. Assuming that the color coded value is 25,000 ohms plus minus 5%. So 25,000 by 0.05 equals 1,254. For the plus side, add 1,250 to the color coded value of 25,000. 25,000 plus 1,250 equals 26,250 ohms. That is the maximum deviation for that resistor. Beyond that, the resistor will not be fitted for the circuit which requires such tolerance. 5. For the side, deduct 1,250 from the color-coded value of 25,000. 25,000 to 1,250 equals 23,750 ohms. That will be the minimum deviation for that particular resistor. Far beyond that, the resistor will be considered to be defective. 6. Finally, the value of the resistor with colors red, green, orange, gold is 25,000 ohms with a deviation of +5 and -5. 23,750 ohms, 26,250 ohms. Testing resistors using analog multitester. 1. Get the range value of the resistor by applying resistor color coding. 2. Calibrate the ohm meter. 3. Set the multitester to ohm meter range, x1, x10, x100, x1k, x10k, x100k, depending on the resistance value. Probably higher ranges first until you have a clear reading. 4. Place the test probe to the 2-terminal lead of the resistor. Since the resistor do not have polarity, place the test probe in any of the resistor's terminal lead. Don't touch the test probe while testing. Good resistor. The meter reading should be within the range value of the resistor. Percentage value equals coded value x tolerance equals 270,000, 0.05, equals 13,500. Minimum value equals coded value, percentage value equals 270,000, 13,500 equals 256,500. Maximum value equals coded value plus percentage value equals 270,000 plus 13,500 equals 283,000. Range value 256,500, 283,000, within the tolerance allowable value. Defective resistor. 1. The tester pointer does not deflect at all. The resistor is open. 2. The tester pointer deflects to zero resistance in any range multiplier. The resistor is shorted. 3. The resistance reading has big difference to the resistor range allowable value. The resistor is out of tolerance. Note, all defective and burned out resistors should be replaced with a new one, with the same resistance values, colors, and power rating, size. Testing resistors using digital multimeter. Testing resistors using digital multimeter. 1. Remove power from the circuit containing the resistor. 2. Isolate the resistor from the circuit. 3. Inspect the resistor. 4. Read the resistor value visually. 5. Prepare a digital multimeter, DMM, to measure the resistor. 6. Measure the resistance. 7. Determine the actual resistance of the resistor. 8. Reattach a resistor that gives an accurate reading.